So we're going to do a simple test here today with the TrackMount 201. All the terminals are labeled over here with a definition of what each one stands for. L1 and L2 are right here and here. That's your line power in, line 1 and 2. Your relay is next, normally open, normally closed, and common. This is normally open. Normally closed has nothing on it right now because we're just testing for switch closure on normally open. And then common is right off here. We're hooked up to the ohm meter right now, obviously, since the relay is de-energized, we're getting an OL on the display. Then we move on to the sensing circuit. We have the ground, which is I put the green alligator clip on there. And then the low and the high are just the two yellow, low, and then high is on the right-hand side all the way at the end. We have the wires coming around here. I'm going to show you how that works in a second. So right now, let's plug this in. The sensing circuit is just sensing for continuity between the ground and the high probe. When it sees a connection between the two, the relay energizes. And this happens with conductive liquids. Obviously, if the resistivity of the liquid gets too high, it makes it more non-conductive. Like for instance, oil, this would not work. But with water, it works perfectly fine because water is very conductive. Or we're just using our substitution box in this case to show what's going to happen at 50K. So 50,000 ohms resistivity. Let's do this first. We have open line here. So what we're going to do is just take our high terminal, high alligator clip, and we're going to touch it to the probe. So we have a good connection between probe and ground, and you hear the relay energize, and there we have good switch closure on the relay. We can also test it using the low probe. So when you hook the low probe up, it's going to act like there's liquid in a tank filling up on two probes. When liquid hits the low probe, nothing happens. But when liquid hits the low probe and the high probe, you're going to see the relay energize. And then even though liquid drops off the high probe, the relay is going to stay energized until liquid drops off the low probe. And in this case, when we take the low probe clip off, the relay de-energizes immediately.